Assalamualaikum and hello everyone. I am Umaira. Today I will present about ethical issues in the profession of an heating and cooling system engineer. Okay, so let's look at what is HVAC engineer. HVAC engineer is they install and maintain system that regulate temperature and air quality. Okay, for the next slide, I will talk about pathway to become an HVAC engineer. Okay, first of all, to become a HVAC engineer, the education required is bachelor's degree in mechanical engineering or HVAC engineering. You also need to have certifications in energy system or green building design. For example, LEED. Okay, not just that, you must have additional skills in thermodynamics and fluid flow. Lepas tu, HVAC design software, for example, HAP and AutoCAD MEP. Not just that, you need to have knowledge about building codes and energy standard. What is their responsibility? HVAC engineer is responsible for designing, installing and maintaining heating, ventilation and air conditioning system in building. So, their responsibilities include designing HVAC system, ensure compliance with safety and energy regulation, and last, supervising installation and maintenance work. Okay, for the next slide is about ethical issues in HVAC engineer. Okay, there are many issues that happen, but I will give you two examples. Okay, the first one is the common ethical issue in this profession is cutting costs by using cheaper or substandard components. For example, a contractor might ask an HVAC engineer to approve a cheaper refrigerant or a smaller than required size to save money. The next one is about, in one case, engineers are at a solar or HVAC consulting firm face pressure to use cheaper materials that compromise energy efficiency and long-term sustainability. These two scenarios can lead to poor cooling performance, higher energy usage, system failure, health risk due to poor ventilation or air contamination. So, if the HVAC engineer agrees, so the building occupants may suffer discomfort or health issues and the system may fail early. Okay, now let's move on to the Code of Ethics Commission. Okay, based on the engineering ethical standards such as the IEM Code of Ethics, engineer must protect public safety, health and welfare. Next, engineers shall be honest and impartial in their work. They cannot just do it saja-saja. Okay, so in this situation, if the engineer approve low quality design, it will violate public trust and environmental responsibility because it risks indoor air quality and building safety. So, HVAC engineer must make decisions that prioritize safety and performance, not just cost cutting that compromise quality. Okay, we will go to solutions and equity in HVAC engineer. Okay, how to resolve the ethical issue? Okay, to address this issue, several actions can be taken. Okay, the first one is engineers must report concern through internal ethics channels or community or anything. So, they will in that they can document everything and keep written records of recommendation to avoid blame if a system fails due to reject advice. The next one, they must follow official standards. They need to refer to ASHRAE guidelines to justify proper system sizing and materials. Next, they can educate the client or contractor. They have to explain the long-term risks, maintenance costs and safety hazard of using substandard parts. So, the last one, they shall offer other alternatives such as suggest cost-effective but still compliant, but that not compromise safety or performance. Okay, we have come to the end. So, in conclusion, HVAC engineers plays a vital role in ensuring comfortable, safe, and energy-efficient buildings in public health and sustainability. Then, they need to make good decisions, such as pressure to cut close, because this will impact safety, energy use, and environmental outcome. So they have to upholding codes or ethics to ensure long-term trust and professional integrity. Okay, that's all from me.
Hi and Assalamualaikum. My name is Nur Ain Shakila binti Abdul Muttalib. So in this video, I will talk a little bit about a profession called material engineer. So before we start, I believe that students who wanted to pursue in material engineer might be asking either what degree that they should take, also what skills that they need to sharpen, and what does material engineer solve. So, to become materials engineer, students typically take bachelor's degree in material engineering or material science. During this program, students will learn about the different types of materials such as metals, ceramics, polymers, also composites. And not just that, they will also learn how materials behave under conditions like stress, heat, also corrosion. For example, students learn why aircraft wing uses aluminium alloy or carbon fiber composites. This is because materials are strong but they are lightweight, which is critical for aviation safety and fuel efficiency. Next, skills. What skills make a strong material engineer? A material engineer must have a strong understanding in material properties such as strength, hardness, fatigue resistance, also corrosion resistance. They also need practical skills in tensile testing, impact testing, and failure analysis using microscope observation and modeling software like ANSYS. So, for the example, in the automotive industry, a material engineer must evaluate whether the steel used for the car chassis can survive fatigue stress or not. Last but not least is responsibilities. Materials engineers are responsible for choosing the right material for a product, testing material, and ensuring it meets safety and quality standards. For example, if a building is constructed in an earthquake-prone area, the engineer must select the steel with high ductility so that the structure can bend without collapsing. So for the next slide, I will discuss a little bit about where can ethics go wrong. So here, the issue is using lower grade materials to reduce production costs. For example, a material engineer discovered that a supplier has secretly modified the composition of an alloy by replacing a portion of high quality titanium with a cheaper aluminium. For what? To reduce the cost. However, when the material engineers report this issue to the manager, that their product has indeed passed the initial testing, but when it tests under high temperature condition, the product failed to operate efficiently. The manager said, just accept the batch because he wanted to avoid delayed production. Here, I have included a realistic scenario, which is a batch of grade 5 bolts advertised as high strength but actually made using cheap, overstretched steel. Engineers were instructed to approve without full testing. Before we discuss about how to solve this issue, I will talk about the code of ethics. So first, the code principle is engineers must prioritize the safety, health, and welfare of the publics in all decisions. So what is the issue that related to this code principle is approving a lower grade materials for aircraft components increases the risk of structural failure. So for the analysis, I put here, the engineer is placed in a conflict between production deadlines and public safety. Last but not least is ethical standard, which is duty to protect public safety. So now is the time to discuss how can we solve the issue. So the resolvement step that I chose is reject the non-compliant material using technical justification, where material engineers can provide a documented report that shows the alloy composition, test results, and the risk. They can explain that approving unsafe materials actually violates the engineering law, safety standards, and also code of ethics. So here I have put professional ethics and substantive ethics. For in terms of professional ethics, a material engineer must not approve materials that fail to meet specifications. And substantive ethics protect public welfare by ensuring safe, trustworthy materials. So that's all from me. Assalamualaikum.
Hi, Assalamualaikum. My name is Ain Hawani, and today I am going to present about biomechanical engineering. So actually, biomechanical engineers combine mechanical engineering with biology and also medicine to understand better on how our body works and create technology that can support our health and also our movement. They studies about how bones, muscles, and joints works and also use engineering to solve these medical problems. They also design devices such as prosthetics, implants, and exoskeleton. They help to develop tools that can aid in recovery. By blending engineering and also biology, this field can actually improve healthcare, boost human performances, and also make medical products much more safer and more effective. To be an biomechanical engineers, we must have a bachelor degree in biomechanical engineering or biomedical engineering or mechanical engineering with a specialization in biomechanics. Also, we can take a master degree in advanced biomechanics, orthopedic engineering, medical device design, tissue engineering, computational modeling of the human body. Next are the key skills needed in this particular profession. First, we must have a mechanical analysis skills, which is you must understand on how forces affect on the body. We must study about how bones, muscles, and joints are used in mechanics and solve movement-related problems with engineering. Also, design a safe and effective medical devices. Next are biological and anatomical knowledge. So, we must understand how the body works and also how the body moves. So, we must make sure that the design that we do fit well with the body tissues and also organs. We must work easily with doctors and medical teams, also create a medical solution that are safe and comfortable. Next are problem solving and also critical thinking. So we must come up with a new solutions to medical problems. We must check how devices works with the body. We must fix problems in design and also help to make the devices and the treatment to be better. So these are the responsibilities of a biomechanical engineers. First, the biomechanical engineer, they must design medical devices. They must study human movement and also body mechanics. Then they also must test and evaluate the materials. So this is an example on ethical issues that happens to a biomechanical engineer. So the scenario is a biomechanical engineer finds a flaw in a hip implant and it can make the implant to fail early. But the company still wants to release it to save the money and save time. If the engineer says nothing, the patients could be harmed or need more surgeries. So these are the code of ethics that are related to the ethical issue. The first one is integrity. So the engineer must be honest about the flow. Hiding it can meet the company's goal, but it will break this principle. Next one is objectivity. The engineer should not let the pressure from the company to influence their judgment. Their decision must be based on the patient's safety and not profit. The next one is confidentiality. So the engineer must report the flow to the right internal team and communicate about the issue clearly. They should not hide or misuse this information because this can risk the patient's safety. And these are the way to resolve the ethical issue from earlier. First is follow the safety standards strictly. They must ensure all the devices are fully tested before being used. Next are be honest about the risk. So report the flaws or concern immediately even if it delays the project. Next is prioritize the patient's well-being. They must make the decisions that protect the user and not the profits or the deadline. So that's all from me. Thank you.
Hello, my name is Elizabeth Zatim. I am from EM110I class, Faculty in Mechanical Engineering. Today, I would like to tell you about mechanical engineering profession, namely automotive engineering. What is automotive mechanical engineering? Automotive engineering is the branch of engineering that focuses on the design, development, production, and operation of vehicles, including cars, trucks, motorcycles, and other types of vehicles.
First, let's talk about the education pathway for automotive engineering. To start, students need a strong foundation in high school, especially in math, physics, and chemistry. These subjects are important because vehicles involve mechanics, energy, motion, and materials. Next, most automotive engineers pursue a bachelor's degree, usually in mechanical engineering, automotive engineering, or sometimes electrical engineering. This is where students learn about vehicle system, design, material, and manufacturing. Some engineers continue with a master's degree to specialize in areas like electrical vehicle, autonomous system, or advanced design. This is also helpful for research and leadership positions.
Alright, so what skills required in automotive engineering?
First are the technical skills. Engineers must know mechanical design, use CAD software, understand engines and powertrain, and work with control system and embedded electronics. Second is electrical and electronic knowledge, which is extremely important today because modern cars rely heavily on electronics, especially hybrid and electric vehicles. Third is material science. Engineers must know which materials are strong, lightweight, heat resistant, or best for safety. And finally, automotive engineers need strong problem solving and analytical skills because they are constantly identify issue, improving vehicle performance, and making design safer. Responsibilities in automotive engineering. Automotive engineers have four main responsibilities. The first is design and development. This involves creating new vehicle parts, designing using software, prototyping and testing ideas. Second is testing and quality assurance. Engineers run different tests to make sure vehicles are safe, reliable, and meet all standards. They analyze any engineering problems that appear. Third is manufacturing and production. Some engineers work in factories and supervise production lines and ensure everything is made correctly. And last, customer and market focus. Engineers also need to understand what customers want, like safety feature, comfort, fuel efficiency, and design vehicles that meet market demands. There are also ethical issues in this field. One example is safety compromise. When companies use cheaper, lower quality material to save costs even though it reduces vehicle safety. Another example is concealing crash test fails, meaning hiding poor safety test results to maintain a good rating. This is extremely unethical because it puts people's life at risk. So, how to resolve this ethical issue? To solve this issue, safety must always come first. Companies should reward safe engineering decisions instead of rushing projects just to meet deadlines. Engineers must follow all safety protocol and ensure a vehicle is not released until it's passed all tests. We also need ethical and inclusive vehicle design. For example, adjustable seating and control help different types of driver. And using diverse crash dummies improve safety for everyone, not just one body type. Alright, so that's all from me. And that's an overview of education, skill, responsibilities, and ethics in automotive engineering. Bye!